Hello GATE aspirants, welcome to part 12 of GATE quantum mechanics series. Question number 2. A matter wave is represented by the wave function psi of x, y, z and t. A is to I 4x plus 3y plus 5z minus 10 pi t, where A is a constant. The unit vector representing the direction of propagation of this matter wave is. Now this exponential part, this first part contains that direction. So here k bar will be equal to 4x cap plus 3y cap plus 5z cap. So from here we can calculate k cap. K cap will be equal to k bar upon magnitude of k bar. So this is equal to 4x cap plus 3y cap plus 5z cap upon square root of 4 square, which is 16, plus 9 plus 25. So this is equal to 5 root 2. So this is equal to 4 upon 5 root 2 x cap plus 3 upon 5 root 2 y cap plus 1 upon root 2 z cap. So here option A is correct. Next question. A light source having its intensity peak at the wavelength 289.8 nanometer is calibrated as 10,000 Kelvin, which is the temperature of an equivalent blackbody radiation. Considering the same calibration, the temperature of light source having its intensity peak at wavelength 579.6 nanometer is. Now we know lambda m, that is the wavelength corresponding to the maximum radiation, into t is equal to constant. This is Wien's displacement law. This constant is equal to b. So this is a constant. So 289.8 nanometer into corresponding temperature, that is 10,000 Kelvin. This will be equal to lambda 2, which is 579.6 nanometer into corresponding temperature. So here lambda 1 T1 is equal to lambda 2 T2. So T is equal to 289.8 upon 579.6 into 10,000. And this is equal to 10,000 and this is 1 by 2. So this will be 5,000 Kelvin. So answer is 5,000 and answer given in the answer key is 5,000 to 5,000. Next question. 3 non-interacting bosonic particles of mass m each are in one-dimensional infinite potential well of width a. The energy of the third excited state of the system is x into h cut square pi square upon ma square. The value of x is. Now we have to find out energy of the third excited state. Now what will be ground state? That means all particles will be in ground state. Then in first excited state, 2 particles in first state and 1 particle in second state. Then second excited state will be 1 particle here and 2 particle here. Since these are bosonic particles, that's why we are drawing these configurations. And third excited state will be all the particles will be in second orbit. So En will be n square h cut square pi square upon twice m a square. And for this third configuration, I can write E is equal to all the particles are in this state. So this will be 3 into 2 square h cut square pi square upon twice m a square. So this is 2 into 3. So that means 6 into h cut square pi square upon m a square. So answer is 6. And answer given in the answer key is 5 to 6. Next question. Consider a spin s is equal to h cut by 2 particle in this state. The probability that the measurement finds the state with Sx is equal to plus h cut is. So S is equal to this and phi is given. Now we know Sx is equal to h cut by 2 0 1 1 0. This is 0 1 1 0 is Pauli X matrix and this is corresponding spin matrix. So this is for h cut by 2 and corresponding eigenstate is this 1 by root 2 and 1 1. So this is the corresponding eigenstate. So we have to find out probability of this phi state in this state. So this is equal to, this is given by probability of getting h cut by 2 is equal to inner product of this psi 1 psi and we have to consider inner product of psi phi 1 as well. So phi 1 is to phi 1. So this will be equal to 1 by root 2. This is phi 1 is this. So we have, this is in Ket form, so we have to write bra here. So 1 1, then this is equal to, this state is given here, which is 1 by 3, and we have 2 plus I and 2 here, and modulus of this upon this 1 by root 2 1 1, then 1 by root 2 1 1. So this will be 2 by 2, so denominator is going to be 1, so this will be equal to this 1 by 3 root 3, 1 by 3 root 2, and then we have multiplication of this, so it will be 2 plus I plus 2. This is 2 plus I plus 2, and then mod of all these things, mod square of all these things. So that is equal to 1 upon 3 square is 9, root 2 square is 2, and this is 4 plus I. So mod of 4 plus I square. So that is 1 by 18, and 4 plus I is 4 square plus 1 square. So if you have a number like this, a plus ib is equal to z, then mod of z square is equal to a square plus b square. So this will be equal to 16 plus 1, which is 17. So this is equal to 17 by 18. So here option D is correct. Question number 34. Consider a particle in a one-dimensional infinite potential well with its walls at x is equal to 0 and x is equal to L. The system is perturbed as shown in the figure. The first order correction to the energy eigenvalue is. Now this potential function v of x, this is a straight line, so we can write equation of straight line, and we have slope v naught upon L. So this is v naught upon L into x. Now first order correction to energy eigenvalue, so E11, this is equal to psi 1 b psi 1, where psi 1 is ground state wave function. So ground state wave function will be, this is a particle in one dimensional infinite potential with. So psi 1 x will be under root 2 by width, so here width is L, into sine n pi x by L, here n is 1, so pi x by L. So this is psi 1, and we have to calculate this integral now. So E11 will be equal to, this is square root of 2 by L, so this will be 2 by L outside the integration, and potential is V naught by L. So V naught by L, integration is from 0 to L. Then we have sine square pi x by L into x dx. So we have to calculate this integral now. So this will be equal to 2 V naught by L square, and this sine square function can be written in terms of cos function. So this is equal to x in bracket 1 minus cos 2 pi x by L whole thing upon 2, and integration is from 0 to L dx. So this 2 and 2 will cancel out. So this is equal to V naught by L square, and let us use integration by parts now. So we have here first, so let me write here E11, this is equal to V naught by L square. First function is x, and integration of the second function, that is x minus cos 2 pi x, it will become sine 2 pi x by L upon 2 pi by L minus integration of this. So I am using this integration of u v dx is equal to u into integration of v dx minus integration of v dx du dx dx. I am using this. So now here we have minus of integration of this bracket term. So that will be equal to x square by 2 minus, this is L by 2 pi, and integration of sine function, that will become plus here. So cos 2 pi x by L, and again 2 pi by L, so square of this, into du by dx, which is x only, so it will cancel out. So this is the entire integration. So this is equal to v naught by L square, in bracket we have x square minus x into L by 2 pi into sine 2 pi x by L minus x square by 2, and minus minus it will become plus minus. So this will be L by 2 pi square cos 2 pi x by L, and limits are from 0 to L. Now focus on this term. If we put here x is equal to L, then this will be sine 2 pi, which is 0, and if we put x is equal to 0, then also this term is 0. So this second term is going to be 0 anyway. Now for the last term, if we put x is equal to L, then this will be cos pi, which is 1, and if we put x is equal to 0, then cos 2 pi, which is also 1. So we'll get two terms which will be exactly same and subtracted. So this second and fourth term won't give anything. So we have finally v naught by L square, and after putting the limits we'll get L square minus L square by 2 and 0 0. So this is equal to L square by 2. So v naught by L square into L square by 2, which is equal to v naught by 2. So here option C is correct. Next question. Consider a state described by psi, which is equal to psi 2 plus psi 4, where psi 2 and psi 4 are respectively the second and fourth normalized harmonic oscillator wave functions, and omega is the angular frequency of the harmonic oscillator. The wave function psi x at t is equal to 0 will be orthogonal to psi x of t at time t equal to. So here psi n of xt, this is equal to psi 2 xt plus psi 4 xt. But we know psi n of xt is equal to a function which is for the space part, so phi n of x, into time part, which is e raised to I e n t by h cut. So psi n at x0 will be equal to psi 2. So this is addition of these two functions, right? So if we put t is equal to 0, then this exponential part will become 1, and this will be equal to psi 2 of x plus psi 4 of x. And also we know energy, this energy is En is equal to n plus half h cut omega. So E2 will be 5 by 2 h cut omega, and E4 will be 9 by 2 h cut omega. So on similar lines, psi n of xt will be equal to, you have to write psi 2 of x first, then here we'll have, here En will be replaced by E2, so e raised to minus I, and E2 is 5 by 2 h cut omega upon h cut plus psi 4 of x e raised to minus I 9 by 2 h cut omega t by h cut. Here t is also there. So this will be equal to psi 2 of x, and we have here e raised to minus I 5 by 2 omega t plus psi 4 of x e raised to minus I 9 by 2 omega t. Now let us calculate inner product of these two, and it should be equal to 0 because these are orthogonal. This should be orthogonal. So we have psi n of x0 and its inner product with psi n of xt. So this is equal to inner product of all these terms. So inner product will survive only when this I is equal to j, that means psi 2 or psi 4 psi 4. So this is equal to, we are considering this equation 1 and this is equation 2. So this product will give us e raised to minus I 5 by 2 omega t plus e raised to minus I 9 by 2 omega t, and this should be equal to 0. Now let us take this term outside of it. We can take one term on the other side. So this is equal to minus e raised to minus I 5 by 2 omega t, that will be equal to e raised to minus I 9 by 2 omega t. That will give us minus 1 is equal to e raised to I 2 omega t. So this will be equal to, so we also know that minus 1 is equal to e raised to I pi. So by comparing these two, we will get 2 omega t is equal to pi, and that will give us t is equal to pi by 2 omega, which is option A. Next question. Consider the potential u of r defined as u of r is equal to minus u naught e raised to minus alpha r by r, where alpha and u naught are real constants of appropriate dimensions. According to the first one approximation, the elastic scattering amplitude calculated with u of r for a wave vector momentum transfer q and alpha tending to 0 is proportional to. Now scattering amplitude in spherical coordinates is given by this function. F of q is equal to minus twice m by h cut square integration 0 to infinity u of r sin qr by qr 4 pi r square dr. So we will calculate this now. So f of q, this will be equal to, this potential is negative, so this minus sign will cancel out. So this is twice m by h cut square. Then u naught is constant and this 4 pi is constant. So integration from 0 to infinity e raised to minus alpha r by r into sine qr by qr into we have r square dr. So this one r will cancel out and this r also cancel out. So this is equal to 2m into 4 pi is 8 pi m u naught upon h cut square, and this is integration 0 to infinity, and here we have e raised to minus alpha r sine qr dr. And this q is also constant, so we can take it outside. And here this integration, value of this integration is given, so this will be equal to 2 pi m u naught upon q h cut square, and this is equal to q upon a square plus q square. So this one q will cancel, and this is equal to 8 pi m into u naught upon h cut square 1 upon a square plus q square. Now if we see this, look at this, as this alpha tends to 0, this is alpha actually, so if as this alpha tends to 0, this will be proportional to 1 upon q square. So f of q is proportional to q raised to minus 2, so option A is correct. Next question. For a 2-nucleon system in a spin singlet state, the spin is represented through the polymatrices sigma 1 and sigma 2 for particles 1 and 2 respectively. The value of sigma 1 dot sigma 2 is. So consider sigma 1 dot sigma 2, and these are polymatrices. So this will be equal to sigma square minus sigma 1 square minus sigma 2 square by 2. How did I write it? Because we know sigma is, if sigma is equal to sigma 1 plus sigma 2, then magnitude of sigma square will be equal to sigma 1 square plus sigma 2 square plus 2 sigma 1 dot sigma 2. So from there you can write this. Now it is a singlet state, that means both of them will, so net spin will be 0. For singlet state S is equal to 0. So for singlet state, this sigma will be 0 basically. So this is equal to sigma 1, sigma 2, this is equal to, this will be 0, and we have here sigma 1 square. So sigma 1 square is 3i. So we have minus of 3i upon 2. I have solved the same question in a previous video, so you can go back to that video and see it again. So this will be equal to minus 3. This question is repeated. So answer given in the answer key is -3 to -3. Next question. The normalized radial wave function of the second excited state of hydrogen atom is given by this expression, where A is a Bohr radius and R is the distance from the center of the atom. The distance at which the electron is most likely to be found is y into A. The value of y is. So we have to calculate the probability. So P of R is equal to magnitude of R square into R square. So this will be equal to, we have to take square of this, so that is 1 by 24. Then this will be a raised to -3 and r square by a square, a raised to minus r by a into r square, which is equal to, this is a to the power 5, so 24 a to the power 5 into r raised to 4 e raised to minus r by e. Now we have to find maxima of this function, so dp by dr, and this should be equal to 0 for maximum. That gives us, this first part is constant only, so we have to consider this part only. So this will be equal to 4 into r cube e raised to minus r by a plus e raised to minus r by a into r raised to 4, and its derivative is -1 by a, and it should be equal to 0. Now this exponential part cannot be 0, so you'll get 4r cube is equal to this part, which is r raised to 4 by a. That gives us 4a is equal to r. That means y is equal to 4. So answer here is 4, and answer given in the answer key is 4 to 4. So these were all the questions from quantum mechanics part in GATE 2021 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.